Let's refresh our memory about graphing lines. Transformations still work on linear functions as well. So I'm going to show you a couple of things. One, we're going to do the same thing that we've been doing, and that is to graph our parent function as well as our transformed function. So our parent function is linear, and it's what we call the identity function because it would be 0, 0, and then when I plug in 1, 1 is the same thing as 1, 2, 2, 3, 3, 4, 4, and you can see the pattern as it goes all the way up and down our graph. This is what we call our parent function. It's the identity. We can see that it has a slope of 1, goes through the origin. But let's take a look at these transformations and see what we have. So we can take a look at our points that we're going to use to graph. So the first thing I want to look at is going to be on the inside. We have a horizontal shift because it's on the inside. X minus 3 is equal to 0, x is equal to 3. We have a shift over to the right at x is equal to 3. This is x is equal to 3. We can see we have a vertical shift upward of 2. So y is equal to 2 because we're going to go up 2 units, and that's going to be right here at y is equal to 2. And then we also have a multiplier in front, which means we're going to get our y values and multiply it times 1/2. So let's take a look at our values for our parent function. Remember, it was the identity function, so we've literally found 0, 0, 1, 1, 2, 2, 3, 3. We found -1, -1, -2, -2. So we found all those points. Now what we're going to do, using our transformations, we're going to start at our new origin, which is right here, where the 3 to the right and the 2 up intersect. That's going to be my origin, and I've graphed this point already. Now don't forget our multiplier. Remember, our multiplier says you're going to multiply times 1/2. So my y values are going to be half of that, half of that, half of 0 is still 0, 1/2, we're going to get 1, and then we're going to get 3/2. And if I would have done 4, 4, we would have gotten 2. So I'm going to show you that real quick. So we're going to graph the point 0, 0, which we did. That's our blue dot. Let's graph 2, 1. Now I know I skipped the other one, but you'll see why. I'm going to go over 2 and up 1. And I'm going to go down here and graph this point of 4, 2. From my new origin, I'll go over 1, 2, 3, 4, 1, 2. We learned that when we were graphing lines that we can go from one point to the other. In this case, we went up 1 over 2, up 1 over 2, up 1 and over 2, and we can go down 1 and 2 to the left, down 1 and 2 to the left, and we can see that these points are lining up into a line that's going through here. So we can see that it has our slope of 1/2. So we graphed it using transformations, but let's take a look and see if we can graph this the old-fashioned way. So I'm going to put it in red. So if I were to simplify this, I would do my distributive property, and I would get 1/2 x minus 3/2, and then plus 2. Then I have to figure out fractions here, right? So remember that 2 is the same thing as 4 over 2. So I'm going to show you what I mean. So I have -3 over 2, and then I'm going to change that 2 to 4 over 2, because 4 divided by 2 is 2. When I add these two together, I get a positive 1/2. So what does that mean for my equation? That I have a slope of 1/2 x at the y-intercept of a positive 1/2. So let's pretend we don't have my yellow axes here, and we go down to my original axes, and we can see our red point right here. That is at 0, 1/2, and then from there I go up 1 and over 2, and up 1 and over 2. And you can see that we're landing right on the same line. The transformations actually made it look easier to find some points, but either way, we were able to graph a linear equation. Now let's turn our attention to graphing the absolute value. We're going to do both the parent function as well as our transformed function. So the first thing we need to do is jot down some things about what we know about our parent function. It's absolute value, so normally it goes like this, a V shape going upward. What we have in terms of our transformations, if I always notice, I always start on the inside. That is what we call a horizontal translation. And I would start off with x plus 1 is equal to 0 and find that x is equal to negative 1. That means that we're going to move our new origin 1 unit to the left. So I'm going to go on ahead and graph that in a dashed line. This is x is equal to negative 1. Then I'm going to look at my vertical shift, which is minus 3, and that means I'm going to go down 3 units. So I'm going to go down 3 units. That's at negative 3. Y is equal to negative 3. That's going to be my horizontal axis. And that makes up my new origin. So my new origin is right here. That's going to be at the point negative 1, negative 3, because we went down 3 units. All right, and let's take a look at if we have a multiplier. In this case, we have a multiplier of negative 2. So that means we're going to have a vertical stretch, and we're going to have a reflection going the other way. So what does that mean about my graph? Instead of actually going upward V, we're going to have a downward V. And notice I drew it a little skinnier because it's going to be stretched. So let's take a look at our points for absolute values. So our points would be at 0, absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2, and if I go to the negative, absolute value of negative 1 is positive 1, and absolute value of negative 2 is positive 2. Now don't forget our multiplier. Our multiplier was to multiply our absolute value times 2. So I'm going to write it like this, 2 times the absolute value of x. So here we go. I'm going to multiply that times 2, I get 4. Multiply this times 2, I get 2. 0 times 2 is 0. 1 times 2 is 2. And 2 times 2 is 4. Now, don't forget that negative, so I actually had a negative 2 multiplier. So I'm going to go ahead and just make all these negatives. Well, 0 is not positive nor negative, so we're not going to worry about that one. But we will worry about the other y values. So now we're ready to graph, starting at our new origin. Notice I'm going to graph, I always start out graphing the new origin, because that is actually one of my points on my graph. So then I'm going to graph the point 1, negative 2. So normally we would go over 1 and up 1, but because our y value is being multiplied by negative 2, I'm going to go over 1 to the right and down 2. Then I'm going to graph 2, negative 4. Normally we would go over 2 and up 2. 2 is the y value. We'll multiply that times negative 2 gives me negative 4. So I'm going to go over 2 and then down 1, 2, 3, 4. The next one would be 3. Normally it would be 3, but when I multiply it times my negative 2 is going to be negative 6. So I'm going to go over 3, 1, 2, 3, and then down 6. 1, 2, 3, 4, 5, 6. So we can see it going like this so far. And we can see the same thing happening on the other side. I'm going to plug in negative 1 and go down negative 2. So I'm going to go to the left 1 and down 2. Then I'm going to go down 2 and down negative 4 from my new origin over to the left 2 and then 1, 2, 3, 4. And again, we can go 3 to the left. Normally we would go 3 up, but because we're multiplying by negative 2, 3 times negative 2 is negative 6. I'm going to go down 6. So that's 4, 5, 6. And we can see our absolute value graph in that manner. So notice normally we would have like a slope of 1, and now we have a slope of negative 2 coming this way, going down 1, going over 1 and down 2, or going down 2 and over 1, whichever way you do your slope.